Automatic, Addison.
In this tutorial, we are going to learn how to use Python databases and other advanced features. Managing database connections is important for logging sensor data, storing robot configurations, or even tracking operational data in real-time robotics applications. Let's begin by creating a new file called databaseconnection.py. Going to go over here, let's click new file, and we'll do database underscore connection.py. Okay, and we'll use SQLite, which is a built-in Python library that allows you to interact with SQLite databases, and this makes it a good choice for demonstration purposes and smaller projects. So import SQLite 3, and let's create our method def create underscore connection db database file. Okay, let's just create a comment here. I'm going to say this is a doc string, create a database connection with the SQLite database specified by DB file. Okay, and let's do con equals none, try con equals SQLite 3.connect DB file, print SQLite database version, SQLite 3, SQLite version. Accept. And okay, so I did my try, accept. Finally, let's move over here so you can see everything. Okay, and then let's go over here and let's do if name equals main. If this is the main file that's run, we do create connection example.db. Okay, let's see the whole thing. Let's move this down so you can see it all in its glory. Look at that, beautiful script. Okay, so this script attempts to create an SQLite database specified by the file name. And if example.db doesn't exist, SQLite will create it automatically when we try to connect. And this connection is closed immediately after being opened to ensure there are no loose ends. Let's run this script to test our database connection. Okay, I press play, and it's kind of hard to see. Let's see if we can bring this up here. You see SQLite database version 3.45.1. So you should see the SQLite database version printed, indicating that the connection was successfully established. And if there's an error, it will be printed instead. Okay, now let's clear out our terminal. Let's close this file. And let's dive into recursive functions, a technique that can help you solve problems that involve nested structures or repetitive tasks. We'll demonstrate recursion with the robotics-related example, navigating a robot hierarchy. Let's say we have a robot structure where each robot can have multiple sub-robots. Our task is to calculate the total number of all robots and sub-robots within this hierarchy. Let's create a new file over here called recursive_robotics.py. And let's create a class robot. And let's do def init. Okay, we do self comma name. Do self.name equals name. Do self.subRobots equals bracket. And let's do def add sub robot self comma sub robot. And let's do self dot sub robots dot append of sub robot. Okay, and then let's create a function out here called def count robots robot. Do our doc string here, and we're going to say return the total count of robots in the hierarchy using recursion. Let's go to the next line. Okay, and we're going to do a for loop. So for sub robot in robot dot sub underscore robots total plus equals count robots sub robot. Okay, and this is write a comment here, recursive call for each sub robot. And then we'll do over here, return total. So let's go back to the top and see what we've done here. So here we define a robot class with the method to add sub-robots, and the count robots function starts counting with the current robot. Let's go down here. So the count robots function starts counting with the current robot, then it recursively counts each sub-robot in the sub-robots list. So now let's create a robot hierarchy to test our recursive function. Root underscore robot equals robot root. Okay, now let's create a child robot. Child underscore robot 1 equals robot, and let's say child 1, and let's do child underscore robot 2 equals robot child 2, and let's do sub child underscore robot 1 is equal to robot sub child 1. Root underscore robot dot add sub robot. Let's do child underscore robot 1. Let's do root underscore robot dot add sub robot. Let's do child underscore robot 2. And let's do child underscore robot 1 dot add sub robot sub child robot 1. And let's print total number of robots. Do count robots root robot. So save. Okay. So now let's run our script. Okay, and let's see what the error is. Okay, it looks like we have an error here. Let's add, to fix this, let's try to use the variable before initializing it. So I'm going to go over here under the count and let's do if robot. These are just some safeguards here. If robot is none, return 0. So if there's no argument there, return 0. And then let's do total equals 1. So this count the current robot. Okay, and then under here, we're going to sum up all sub robots. All right, and now let's run it again. See what we get. Okay, there we go. Okay, so now let's expand this out so you can see. Let's clear all that and run it again. Okay, here we get total number of robots 4. So you can see that, oh boy, everything's going all out of the whack here. Okay, let's move this over. So we added a safeguarded here. So if this argument's empty, return 0, and we count the current robot, total equal 1. And then sum up all the sub robots. So the total number of robots is 4. So you'll see the total counts of robots in the hierarchy right there, which includes the robot, the root robot, its children, and sub-children. The root robot, its children, and the sub-children here. So 4 robots in total. Okay, let's clear out the terminal window. Let's close this file. Now let's explore working with modules in Python, a fundamental concept that allows you to organize your code better, making it more readable, maintainable, and reusable. For robotics engineers, using modules can help structure control systems, sensor integration, and interaction logic into separate components. Let's create a file called robotmodules.py. Robotmodules.py. Okay, save it. Control S. Now let's create a module that we'll use as a utility for our robotic operations. This module will include functions to calculate the area of different shapes, which could, for example, be useful in path planning or space management in robotics applications. Now let's create another file and let's call it geometry. Geometry.py. Okay, and in this one, let's type the following code in here. First method is called rectangle underscore area, length, comma, width. Return length times width. Def, circle, area, radius. Do from math import pi do return pi times radius and then exponent 2 pi r squared. That little double asterisk there is the exponent. So radius raised to the power of 2. So we'll save that and let's go back to the robotmodules.py. And let's import that. Import geometry. Okay, and let's define a main function, def main. And let's do rect area equal geometry dot rectangle area 5, 3. And let's do circ area is equal to geometry dot circle area 7. Let's do print f area of the rectangle. Let's do rect area. Let's do print f area of the circle, circ area. If name equals main, and do main. Save. Okay, take a look at the whole program here. Come on, expand this out. There we go. Okay, so here it is. We import geometry, we create our main function, rectangle area function. We use that one. We use as arguments 5 and 3, and then a circle area, and we use as argument 7. And area of the rectangle we print out, and then area of the circle we print out. So 5 times 3 is 15, length times width. Get the area of the rectangle. We should expect 15 here. And then we have pi and then r squared, with radius being 7. So 7 squared is 49. 7 times 7 is 49 times pi. And that is what we should get. So 49 times pi is what we should get for the area of the circle. Let me do that over on this side here. 49 times pi. What do we get? 153.9. So that's what we should get when we run this. So let's run our script and let's see it in action. And there we go. Area of the rectangle is 15 and the area of the circle is 153. So you had length times width, we return it, and then circle area, pi r squared, and we return it. We imported geometry to be able to get access to these functions, and then we actually used these functions from the geometry library we created in our main function in this file. Let's learn how to create a graphical user interface, or GUI, using Python. This skill is helpful when you need to create an interface for interacting with robots, such as controlling movements or monitoring sensor data. Let's create a new file over here called robot_GUI.py. Robot_GUI.py. Come on. All right. And we're going to use tkinter, the standard GUI library for Python, to create a basic user interface. It's included with Python, so you don't need to install anything extra. Let's start by import tkinter. Let's give it a nickname as tk. Let's do from tkinter import simple dialog. Let's create a main function, def main. And let's do root equal tk.tk. All right. And now let's do root.title. And let's do robot control panel. Okay. This will be our title for our GUI, and let's create a method to handle the command. So handle command. Let's do response equals simple dialog dot ask string. And let's go over here. Let's do input, comma, enter a command for the robot. Okay, print f, let's do f, command received, response. Okay, and let's go over here, command button equal tk.button of root text equals send command. Command. Okay, and then our command that we want to execute when we press the command button is the handle command function. So I'm going to equals handle command. right? And let's do command button dot pack of Patty equals 20. That Patty is the padding that you're going to add to create some space around the text and the send command button. And now let's do exit button is equal to tk dot button of root comma text equals exit command equals root dot destroy. And let's do exit underscore button dot pack. And let's make that look beautiful as well by adding some padding around the command exit. This is our exit button because we want the GUI to eventually close. And now let's do root dot main loop. Okay, and now we do this piece down here. If the name is equal to, so if this is run, if this script is run explicitly, we want the main function to execute, which we just wrote. So main, all right. So in this script, let's create some space here so you can see what's happening. So in this script, we create a basic window with the button. And when clicked, this button prompts the user to enter a command, which could hypothetically be sent to a robot. And the main loop method, which you can see down here, keeps the window open and waits for user interaction. All right, so save. And so I ran it. You can see here, we have the send command and the exit right there. And I just press the send command button and it says enter a command for the robot. All right, and let's type stop, S-T-O-P. Let's click OK. And let's see if we got anything down in the terminal. Okay, it's all the way down here. Let's exit. I'm going to move this up so you can see. Okay, let's clear it again. Let's run it again. Okay, so we've got our first GUI right here. All right, so this is our robot control panel. Robot control panel, expanding it out here. That was our title. And we've got the send command button and the exit button. I'm going to minimize this so you can. Okay, and now we're going to click send command. And now we have a dialog button that opens asking for command input. And I'm going to type stop right here, S-T-O-P. Click OK, and you can see the command right here. Enter, go. Let's do another command. Turn right. Okay. And we can just keep typing commands over and over again in this robot control panel. When you're done, just click exit and we're done. And there you have it, a basic GUI for controlling a robot using Python and tkinter. This concludes the Python for Robotics course. Thank you for following along and keep building.